concept, it's all algebra. Okay, it's like a simple concept, and then it's all algebra, right? Now, is it easy algebra or very, very tedious algebra? Tedious. Okay. I think, though, that the matrices are very tedious because you have to do a whole bunch of steps and you're just sort of like just numbers. I think calculus is a little easier because it's more equations and you're just bringing down an equation down to a simple solution. So you start out with it up here and you just have to work it down, work it down, work it down, work it down, and maybe a page or two to work it down to the final simple solution, which comes down to very simple things like the number 3 or something like that. You know, it comes down to very simple solutions once you've worked through it. But the thing that you have to be careful of is that if it takes 2 pages to do a problem, how many homework problems can I give you in a night? 4 or 5? Okay, so you see, it's not like in Algebra 2, you always got 20 problems, and so if you missed 1 out of every 10 steps, you would make, you know, a 90. Well, here if you miss 1 out of every 10 steps, you're going to make a 0 because you're never going to get through a problem without making mistakes. So I have absolute confidence that everyone in here would be able to get a strong A in that class. Okay, but it's going to be like this class. You're going to have to work hard. You're going to have to turn your homework in on time. You're going to have to, you know, do all the good things that you're doing now. But I think everyone in here could get an A in calculus. Okay, and in fact, I think a lot of aspects you would enjoy calculus more than this class, because I think this class, on some of the things associated with trigonometry, it became somewhat frustrating because you never knew, is it talking about between 0 and 180, or is it talking about this quadrant, or do you put all solution, you know, sort of like on that ambiguity that there would be 2 numbers that would both give you sine of 3 pi over 2, which one does it want? And kind of like that, it was always clear in the instructions, but it was always going back and forth, I felt like. So there's a little bit of frustration associated with all that unit circle stuff. Calculus doesn't have that. It's just like, man, you start at the top and then you just work your way down. And then there is an aspect of calculus that you get to that is like factoring, where there's not just a 1, 2, 3 step thing. You got to sort of try something, and that doesn't work. We'll try something else, and you got to sort of not just panic. You might try something that's reasonable based on what you know, and then as you're working down, you see this isn't leading to a solution, so I have to try a different thing. And so you can't just panic when the first thing doesn't work, because maybe there's 3 or 4 different angles on it, and you have to find the one that'll actually lead to a solution. If I show you how to do it, like I say, I'm confident that everyone in here could get a strong A in that class. Okay. Chapter 8, Section 5, area of triangle. Okay. So typically, how have we done a triangle? Like if you just have a triangle, what's the area of a triangle typically?
Base times height divided by 2.
1/2 base times height. You're right. Okay. So you got to kind of know the H, and then the problem though is that always works. But the problem is, what's the easiest way? If I were just going to tell you a triangle, what would be the easiest way for me to communicate to you the triangle that I'm thinking of? It would have how many corners? 3, right? And the easiest thing would be if I just told you x1, y1, x2, y2, and x3, y3. If I told you those 3 things, does that uniquely tell you exactly the triangle I'm thinking of? Yes. But then is that easy for you to just take that and figure out what the area is? Not really. Because you'd have to think, well, if it's this times this, or this and this, maybe I would have to do the distance formula between here and here, right? And then I know the base. And then I would have to figure out, so I would have to do the distance formula. And then I would need to know this point, so I would have to do what to figure out that point? The midpoint. And then I need to know this, so what do I have to do again? Distance.
Well, would you have to do distance of both sides to make sure that they're even before you found the height in case it wasn't correct?
1/2 base times height always works, doesn't it? I think it always works.
I don't know. I can't remember.
Okay. I think it always does. But what you see is, it would be hard. The easiest way for me to tell you the triangle are 3 points, but then it would be hard for you to find it. So there is a way to find the triangle, the area of the triangle that doesn't involve all that. And the area is equal to plus or minus 1/2 x1, y1, 1, x2, y2, 1, x3, y3, 1. What do those two braces mean?
Sure.
The determinant, okay? Now, why do I put plus and minus?
Because it could be a negative point, or it could be a positive
Well,
point.
the area is always what? Area is always what?
Positive.
Positive. So if you work this and you get a negative number, what do?
And then make it positive.
Make it positive. If you get a positive number, what do? Leave it positive. Okay, and you know how determinants work in a funny way? I'm not telling you which one, x1, x2, or x3 to put first. You can put them in any order, the 3 points, yeah? But if you just randomly put them in a certain order, you might get what kind of number? You might get a positive, or you might get a what? If you get a negative, do you panic?
No.
No, what do?
Multiply by the negative.
Right. That's what the plus or minus is. That just means make it positive. You know, don't go in and rearrange your points and work it again to try to get a positive number. Just change it. If you get a negative number, make it positive. But that's always true. Now, what's the nice thing about that determinant? What's going to make that determinant a little easier? All those ones over there will make it a little easier. Okay? So let's work a couple of problems. So let's say I told you the points were 1, 0, 2, 2, 4, 3. Okay? And then let's say the area is equal to 1/2. And what would I put in here? Will, what would I put in here?
1, 0, 1.
Uh-huh. And then what, Chase?
2, 2, 1.
Okay, then what, Franklin? Okay.
So the order doesn't matter?
Well, the x, y matters,
Yes.
but the order of the points don't matter, because that's the whole thing. If it's negative, we'll just make it positive. So this is going to be equal to 1/2, and then I'm going to draw it like this, because I got to remember after I get the answer, put it 1/2. What's the first number I have? 1 times what, Emily?
2 times 1 minus 3 times 1.
Like that. Ooh, what makes me happy?
It's 0.
So that one we don't have to worry about. And then what, Will?
1 times 2 times 3 minus 2 times 4.
Okay. And so this is equal to 1/2 of what? Minus 1 minus what?
2.
2. So it's minus 3/2. What do I do?
Make it 3/2.
Just make it 3/2. Area is equal to 3/2. Okay? Is that clear?
Yes.
No question. All right. So the area, so we're going to learn a couple of things today. I don't need to really go over that again. Area is equal to plus or minus 1/2 the determinant x1, y1, 1, x2, y2, 1, x3, y3, 1. Okay. Now, if I just gave you 3 points and I said x1, y1, x2, y2, x3, y3. And what if that came out and I calculated the area and it told me that the area was equal to 0? If I had 3 points and the area was 0, what is the only thing that could mean?
Straight line.
A straight line. Boom. Okay. Because you see, if I have a straight line, the area, there is no area, right? If this one was just a tiny bit off of straight, just a tiny, tiny bit off of straight, I would have an arrow. I would have an area, right? So if you're given 3 points and you're asked, are they collinear? what would you do? X1, Y1, 1. X2, Y2, 2. 1. X2, Y3, 1.
Also, if it's 0, it equals collinear.
If it's equal to 0, the points are collinear. Does that make sense? Okay. So you see, you don't even need to memorize that. You just need to understand, like you think, well, that determinant is related to the area. If that's telling me it's 0, those points must be on the same line. Okay? So let's see. Let's see if minus 2, 2, 1, 1, and 7, 5. Are those collinear? What would I need to do?
Find the area.
Yeah. So minus 2, 2, 1, 1, 1, 1, 7, 5, 1. So what is the area? Well, what would I start with?
Minus 2 to 1 minus 5.
Okay. And then Chase, what's the next one?
-2, 1 minus 7.
Uh-huh. And then Franklin, what's the next one?
1, 5 minus 7.
Okay, 5 minus 7, right? Okay, so minus 2 times minus 4, that would be 8. Okay, and then I'm going to put the brackets, and I'm going to remember that I got to multiply by a half. 1 minus 7 is minus 6, is that right? Times minus 2 is what?
12.
12. Okay, and then I have 5 minus 7 is minus 2.
Yes.
So that's minus 2. Does that equal 0?
No.
No. So they are not collinear. Okay. Is everybody good with that? One more thing. If I have x1, y1, and x2, y2, and I said, what is the equation for the line between them? You could work that right now, right? What would you do? You'd first of all find the what?
The slope.
Slope. And then you would say what minus what equals? Y minus y1 is equal to m onto
X minus X1.
m onto x minus x1. So you could do it that way. But, you know, right, the reason we do things with matrices is they allow us to put them into the computer, and then the computer can solve matrices. We could write a program. So rather than going through all of that, let's see if there's a way to do it with matrices. Okay, this is the way you do it. You just say x, y, 1. And this x is going to stay x, and this y is going to stay y. These are the variables x and y. These are not numbers. Okay, and then the point x1, y1, 1, x2, y2, 1. Can you find the determinant of that? Okay, so let me give you 2 points. Minus 1, 3, and 2, 4. What is the equation of the line between those 2 points? I would need to do what, Emily?
The matrix.
Okay, and what's on the first row?
X, Y, 1.
Okay, what's on the second row?
-1, 3, 1.
Doesn't matter which order you go. And then what?
2, 4, and 1.
Okay, so now what is the determinant? It's x times what?
Oh, 3 minus 4.
3 minus 4. And then, Will, what do I do with y?
Negative y times 2 plus 1.
2 plus 1.
Okay, then what do I do with the 1?
1 on the -4 minus 6.
1 minus 4, and then minus 6, right?
Yes.
Okay. So now let's see what that comes out to. I have 3x minus, I'm sorry, 3 minus 4 is minus 1. I have minus x, and then 2 plus 1, that'd be minus 3y, and then that's what? Minus 10 is equal to 0. All right, you see how you set it equal to 0? Okay, so now I would say 3y is equal to minus x minus 10. Y is equal to minus x over 3 minus 10 thirds. Okay, and let me make sure I did that right. I feel like I made a mistake in there.
Should the x be positive when you move it over?
No, because
You just moved the y over.
I moved the y over, but I think I made a mistake here somewhere.
It should be -1 minus 2
Where's that?
on the negative y.
Okay, negative y would be
-1 minus 2.
Negative 1 minus 2.
Okay.
You-
Does everybody see the mistake we made?
yes.
I made. Okay. So then over here, let's start again here. This was what? Plus 3y, right? So then let's move the x and the 10 over there. So 3y is equal to x plus 10. Y is equal to x over 3 plus 10 over 3. And that's the answer. Okay? Now,
You solve for x too, or just y?
it's just y equal mx plus b. Right, it's y equal mx plus b. All right, when I look at this, I would rather just find the slope and do it the other way because I've done it so many times, it's easier for me to do it the other way. But the thing is that if you're going to put it in the computer, this makes a lot more sense because you're already working with matrices. This just becomes a simple matrix function. And so that's why most of the things that you do in the computer, you put it in matrix form and then you program it up, okay? So let's look at the homework. Chapter 8, Section 5. 18 through 20, 24, 35 through 38, 44 through 46, and the bonus is 30. Okay.